In this question, we want to do the following for the function f of x equals 3x plus 2. In part A, we express the slope of the secant line in terms of x and h. In part B, find the slope of the secant line for h equals 0.5, 0.1, 0.01 at x equals 1. What value does the slope of the secant line approach as h approaches 0? Find the equation of the secant line at x equals 1 with h equals 0.01. And graph f and the secant line found in part C on the same viewing window. So let's start with expressing the slope of the secant line in terms of x and h. I'm going to give a little background. There is a formula for slope of the secant line, but I'm going to describe where it comes from. So we'll start with a curve. So we have some curve on our graph, and the secant line is going to be a line that crosses through 2 points on our curve. So I'm going to let x be the first point, and then the second point will be a little bit further down. And we'll say that little bit further down is the amount of h. We would take 2 points on that curve that are associated with that x and h and connect them with a straight line. That straight line is the secant line. So this is the secant line. Now the y values that go with those points would be f of x for this first one here, and f of x plus h for the second one. Now we're interested in finding the slope of that secant line. We have a formula for calculating slope of a line that's y2 minus y1 over x2 minus x1. So we'll use this f of x plus h as our y2 and f of x as our y1. That will give us f of x plus h minus f of x all over, and we're going to use x plus h as our x2 and x as our x1. We have x plus h minus x, and we can simplify that denominator. I'm copying down the numerator, and the denominator, the x's would cancel, leaving me with h. So this gives us a formula for calculating the slope of the secant line. So we label that with m for slope with a subscript of SEC for secant line. So our formula for slope of the secant line is f of x plus h minus f of x over h. That's a general formula for the slope of the secant line. We want to find the slope of the secant line for our function f of x equals 3x plus 2. So I'll start off by finding f of x plus h. Everywhere I see an x, I'm going to change it to x plus h. That becomes 3 times x plus h plus 2. And then I want to subtract f of x. Our function f of x is 3x plus 2, and notice I put parentheses around that function. And that's to make sure that this minus applies to the whole function and not just the first term. In the denominator, we have h. So I'm going to use the distributive property on this 3 and the distributive property on this negative. That will give me 3x plus 3h plus 2 minus 3x minus 2 over h. 3x minus 3x is 0. 2x minus 2, that's a 2 minus 2 is 0. And I'm left with 3h over h. The h's cancel, and I have 3. So the slope of the secant line is 3. Now the reason why the x and the y canceled out in our expression is because our function is a linear function. F of x equals 3x plus 2. If we were to use another function that wasn't a linear function, the slope of our secant line would have the variables x and h in it. So this is the answer for part A. The slope of our secant line in terms of x and h is 3. In part B, we're asked to find the slope of the secant line for h equal 0.5, 0.1, 0.01 at x equals 1. The slope of my secant line doesn't have any variables in it, so I don't have anything to substitute into. But if my function was something other than a linear function, I would have x and h within the slope of the secant line, and I would substitute the different values of h as well as the value of x to answer part B. For this example, part B will have the answer 3 for every value of h. The slope of the secant line is 3 for all of these values of h and x. So it's 3 and 3 and 3 for all 3 of those answers. In part C, we want to find the equation of the secant line. And to find the equation of the secant line, you need the slope and a point on the line. Now we've already found the slope. That slope is 3. This is the slope of the secant line. And we have x equals 1. We need to have the y value at that point. So remember, my function is f of x equals 3x plus 2. F of 1 is 3 times 1 plus 2. That's 3 plus 2, which is 5. So this is the ordered pair that I'll use to find the equation of the secant line. The formula is y minus y1 equals m times x minus x1. We call this point slope form. And I'll substitute the slope as well as my ordered pair into this formula. That gives y minus 5 equals 3 times x minus 1. I'll use the distributive property on 3 to get 3x minus 3 and add 5, and this gives y equals 3x plus 2. Y equals 3x plus 2 is the equation of the secant line. I'm going to zoom out a little bit so we can see our question again. I want to make sure we answer all the parts. And I just noticed that I missed this part of the question right here. What value does the slope of the secant approach as h approaches 0? All of the slopes of our secant lines were 3, and so the slope of the secant line approaches 3 as h approaches 0. Finally, part D, we want to graph f and the secant line in the same window. So I have the graphing calculator right here. And our original function was y equals 3x plus 2. And the equation of the secant line is also 3x plus 2. And to graph them in the same viewing window, they are the same line. So this is a little unusual, but because the function is a linear function, the secant line is the same as the original function. And so we've answered all of the parts on this example. Thank you for checking out my videos. Have a great day.